Hey guys, welcome back to another science lesson with HeyCam Math and Science. This video is about radiation and getting an understanding of what it is and how it is used. So by the end of this lesson, we should all know the different properties and uses of low frequency radiation, know the different properties and uses of high frequency radiation, and also know the dangers of the radiation in the electromagnetic spectrum. So let's pause the video here and take a couple of minutes just to write these down. Alright, so let's start off at looking at the electromagnetic spectrum. These are all the different types of radiation we have. So on the left is the low frequency radiation, and on the right is the high frequency radiation. So frequency just means how many waves there are. So the more, you notice how there's much more waves over here than to the left. So that's high frequency and that's low frequency. Another main characteristic of these is that low frequency radiation has much longer wavelengths. Notice these are much longer than the ones here, and high frequency radiation has shorter wavelengths. So if you remember from previous lessons, the wavelength is from one point to the other point, to the top, or you can do it at the bottom here. Alright, so let's start the lesson by looking at low frequency radiation. So that's all the ones to the left of visible light here. So that includes radio waves, microwaves, and infrared waves. So let's start by going through the different radiation from the very left, and that brings us to radio waves. So radio waves are the longest wavelength of all types of electromagnetic radiation. They range from about a centimeter long to many kilometers, and they can travel large distances through the air or empty space. So they are often used by television and radio networks, mainly because they can travel such far distances. They work by making electrons in the antenna of your TV or radio vibrate, which is then converted into sound or images you can see or hear. Alright, so our next type is microwaves, and these ones have a shorter wavelength than radio waves. As you can see from this image here, the radio waves have shorter wavelength than microwaves down there. So microwaves are often used in radar and communication systems, and they are also very often used in cooking. So when cooking with microwaves, the microwaves have wavelengths of about 0.1 millimeters, and this wavelength is used for cooking. Microwaves are absorbed by water, fat, and sugars in the food, which make the molecule vibrate and ultimately heat up. Heating occurs inside the food without warming the surrounding air, so the air heats the food quickly, but sometimes unevenly. Glass, paper, and many plastics don't absorb microwaves, and metal reflects microwaves. This is why we should never put metal inside a microwave, because the metal reflecting the microwaves can cause a fire to start inside your microwave. So the next type of low frequency radiation is known as infrared radiation. Infrared rays have lower frequencies than visible light rays, the ones we had in the middle of the spectrum here. And heat is transferred from the sun to the earth as infrared radiation. We also learnt about this in the last lesson. All objects emit infrared radiation. The hotter something is, the more infrared radiation emits. And you cannot see infrared radiation with your own eyes, but you can detect its presence as warmth using an infrared camera. So this is an image taken from an infrared camera. Notice in your hand, you'll be warmer towards the center, that's where there's more infrared radiation, and it will be colder towards the outside where there's less infrared radiation. So right in the middle we have visible light, and towards the right we have high frequency radiation, the ones that have much more wavelengths and that are much shorter than the ones on the left. So we'll just take a few minutes to go through these now. Alright, so our first form of high frequency radiation is ultraviolet light. So the meaning of ultraviolet is just radiation with higher radiation than violet light. That's what the ultra part in ultraviolet means. Sunlight contains UV light in addition to infrared and visible light. And our bodies need some exposure to UV light to produce vitamin D, but not too much. UV light is not visible to the human eye, but can burn our skin. And high exposure to UV light can cause skin cancer. So make sure you put on sunscreen. UV light can also cause cataracts in our eyes, so make sure you're wearing approved sunglasses when you're going out in the summer as well. So our body does need UV light, but make sure you're not getting too much of it. Right, and our next high frequency radiation, you guys have probably heard of this one before, are X-rays. These have great penetrating power, and so are used to investigate the structure of objects and to find flaws in metals. They have a very high energy and can also damage cells and tissues, and also affects the genetic material inside the cells. And X-rays are produced when electrons hit a metal surface. So in addition to the first point here, it's also often used to scan our bodies and just to check if there are any flaws or cracks or breaks in our bones. Alright, and our last high frequency radiation, the one on the very right of the spectrum, is known as gamma rays. These have wavelengths of about 100 billionth of a meter, so they are very, very small. Only a thick sheet of lead or a concrete wall will stop them. And gamma rays are produced by radioactive material, nuclear power plants, and nuclear bombs. They can be detected with a photographic film or a machine called a Geiger counter, and they are often used in radiotherapy to target and kill cancer cells. Yep, so that was just some brief information about all the different types of radiation. And we've gone through from radio all the way to gamma ray, so from low frequency radiation to high frequency radiation. So now let's just go through a few of the dangers of the electromagnetic spectrum. So that's just this spectrum here. So as the wavelength of the EM spectrum or electromagnetic spectrum changes, the way the different wavelengths interact with the matter also changes. So as the frequency increases, wavelengths get smaller. As you can see here, wavelength got smaller, so there's much more frequency of the wavelengths. Over here, wavelengths are longer, so there's less frequency of the wavelength. Eventually, the waves are so small that they can interact with cells, DNA, and atoms. That's because they can get into cells because they're very small. And this is called ionizing radiation. So to the left, we have non-ionizing. That means they cannot interact with cells because they're too big. And this side, they are ionizing. And that's when they start to get a bit dangerous. And on the very right, that's where they are the most dangerous. Gamma rays, they penetrate through everything. And only a thick sheet of lead or concrete will stop it from getting through. So this dangerous nature, we use it to our advantage when treating cancer, and it's used to kill cancer cells like we went through in that slide before. Alright, so that brings us to the end of this lesson. Just to compass to see what you need to do next. And hopefully by now you guys all have a rough idea of the different properties and uses of low frequency radiation, different properties and uses of high frequency radiation, and that you also know the dangers of the electromagnetic spectrum. So that's just the ionizing and non-ionizing nature of the different waves. Once again, thank you for watching, and I'll see you guys back online.